this is the solution of the activity number 5, where you have to send a message from the Arduino to the Raspberry Pi when you press on the push button, and then receive a color for one of the LEDs, so basically one of the color of the RGB LED, and then change that color from the Arduino. So once again, let's start to do the Arduino code, and then we're gonna debug the Arduino code with the Serial monitor, and then we're gonna write the Python program on the Raspberry Pi. So let's initialize, I'm gonna remove this. Let's initialize the hardware components. So define button pin, which is pin number 7, and then define RGB red pin, which is 11, and let's do the same for the green and the blue. Green, blue, and we have 10, and we have 9. Okay, in the void setup, what we do is pin mode with button pin input, and then pin mode for the red pin to output. Okay, and then the same for the green, the same for the blue. Okay, so I go quite fast with that because we've already done that multiple times. And then I'm going to open serial communication, so serial.begin with, let's keep the same baud rate, and while serial, let's wait. All right. Now, what do we do? I'm going to also remove that. So we have two things to do, which are, well, actually completely independent. First, we need to read the push button, check when it is pressed, and send a message to the serial. The second action is to receive something from the serial and check what command we have, if it's red, green, or blue, and then apply the command to the RGB LED. So while there is no particular order to do that, you can debug both independently, but let's start with, let's say, the push button, okay? So I'm gonna do the debounce code for the push button once more, unsigned long last time button changed, let's say millis, and then unsigned long button, let's say debounce, delay is, let's put 50 milliseconds another time, and then so unsigned long time now is equal to millis, so we get the current time. We check if time now minus last time the button has changed, if this is greater or equal than the debounce delay, then we can enter this if, and what we can do is do byte button state is equal to digital read from button pin. Then we will need to, so we will need to compare the button state with the previous button state. So I'm gonna add here byte previous button state, and just after we do the pin modes, I'm gonna do previous button state is equal to digital write from button pin. So we have the first state here at the beginning, and then we are going to compare button state. So if this is different than the previous one, then we need to do two things. We need to update the last time the button has changed to time now. Okay, so then the debounce is gonna happen another time. We're gonna do previous button state is equal to button state, and then we can check if button state is equal to high here, because we have a pull down resistor, then the button is pressed. Okay, and let's do serial dot println, and well, what do we send here? I'm not gonna do button is pressed, okay? This is not a log, this is a serial communication from the Arduino to the Raspberry Pi. So let's say we're gonna send button pressed, like this. And here, we're gonna receive button pressed, okay? So very important to agree on what you send and what you receive. And well, I'm first gonna just check if that code is working. So activity 5, compiling, uploading. Okay, let's open the serial monitor and let's press on the push button. Button pressed, another time, button pressed, button pressed. It is working, great. So now let's do the code for the RGB LED. So we have this already. Well, we have the initialization, which is okay. Now let's do, so here in the void loop, make sure you don't make a mistake, okay? And that you don't put the code in the wrong block of code. So that's gonna be here. So if serial.available greater than 0, so that doesn't change really. Then, so if we have received something, we're gonna do string cmd command is equal to serial dot, and guess what? Read string until backslash n with one single quote. And then we do if, and that's where we are gonna check what command we have received, because here we can receive 3 different commands. So if command dot starts with, so the command can start with, for example, read, like this, then we're gonna process the read command. And then else if cmd dot starts with, we have green, okay, else if cmd dot starts with blue, and then let's do another else like I did before, nothing for now. Or maybe what we could do if we receive an error is just to, for example, power off completely the RGB LED, okay, it's up to you. So if we receive the red color, what we can do with the command is first to do cmd dot remove and then 0, 4. Okay, we'll remove, so 0, 1, 2, 3, 4. We'll remove all of that and we are left with the number, but the number is actually a string, so we do, for example, int red is equal to cmd dot to int, like this. And then analog write with RGB red pin and with the red number that we got from the command. And well, we can do the same with every other command. So cmd.remove, but here we don't do 0, 4, because if we do 0, 4, we're gonna remove 1, 2, 3, 4, and we are gonna be left with n column and the number. So we do 0, 1, 2, 3, 4, 5, 6, okay? So as you can see, each command, you will need to process it independently and make sure that it's working. Int green is equal to cmd.toInt. This doesn't change, and then analog. So let's use analog write, the same, but with green and green. Okay, and then for the blue, we do cmd.remove, and how many do we need to remove? 1, 2, 3, 4, 5, so 0, 5, and then int blue is equal to cmd.toInt, and let's do analog write with the blue pin and the blue color. Okay, and now we can try this code actually on the Arduino to check if it's correctly working. And well, if you want an additional debug step, because maybe, well, let's say you want to send the red or the green or the blue command and it doesn't work, you don't necessarily know why it doesn't work. So what you can do, for example, let's say here serial.println, for example, red. So we can just use this when we debug the Arduino with the serial monitor. And then, of course, that's very important. Don't forget to remove any log that you have put first for the Arduino side. So let's upload the code to the Arduino. Let's open the serial monitor. So we still have the push button that will show button pressed. And then let's do red colon 200. You can see it is correctly working and we have 200. Okay, let's do green 100. Okay, we have a different color, and blue 50. Let's do blue actually 200. Okay, and maybe red 0, right, green 0, blue 200. Well, there is something wrong with blue. And well, actually I have checked that I have used, I don't know why, but 19 for the RGB blue pin, so of course that doesn't work. So you can see here that didn't work, we didn't see the command blue change, and then it helped us to actually see that we have an error in our code. So now let's run that again. I'm going to open the serial monitor again and just test blue with 200. And well, the blue is working. Great. So now I can just close that. I could also do a serial print with the blue, okay, to make sure that we receive from serial. And I'm gonna remove, this is very important, any log that I have put which have nothing to do with the serial communication with the Raspberry Pi. Okay, so now the Arduino code is working. I'm gonna upload also the new code, of course, without the serial.println. Okay, the Arduino side is working. Let's go to the Raspberry Pi side. So first of all, we need to initialize serial and everything, but I'm gonna use the code from the previous activity. So select everything. So you can do this by yourself, but I'm gonna do this so it goes a bit faster. And anyway, we have already done that multiple times. So well, I'm gonna remove that also. Okay, just the import initialization and then the infinite loop with the time.sleep, very important. And I'm going to import random here, and let's remove that. Okay. So what do we do on the Raspberry Pi? Well, we don't send anything without receiving anything. So we first need to check that we have received something. So in the while true, if ser.in waiting is greater than 0, again without parentheses, then we do, let's say, message is equal to, and for message we could also do msg, for example. That's the same as using cmd for command. Okay, that's pretty explicit, and that's something you're gonna use very often, so that's not a big deal. And so ser.readline dot decode utf8 dot rstrip. Okay, and then what we do is we check if message is equal to what? Is equal to button pressed. Okay, we send button pressed, we check if we receive button pressed. If we have received button pressed, then we are gonna process the action. And what is the action? Is to choose a random color, so red, green, and blue, and then a random number for that color. Okay, so let's do LED is equal to random dot rand int with 0 and 2, and then the number is equal to random dot rand int from 0 to 255. Okay, and then we're gonna construct the string that we're gonna send. Okay, so the command, and so let's start with cmd is equal to an empty string, and then if led is equal to 1, we do cmd plus red, and then let's do if LED is equal to 2, we do CMD plus green, and then let's do else CMD plus blue. So we have the first part of the command, and then we add CMD plus number, but actually as a string, so we cast the number as a string, and then CMD plus \n. Okay, so we start from an empty string, then we construct it with first the command name, red, green, and blue, and then the number we want to read that we're gonna get here, and then \n for the read string until with the \n. Okay, and then we can do ser.write cmd.encode UTF-8 like this. And let's see if that works. Maybe we can add some prints here because it's easier to debug on Python. We can add some prints. So let's say here print button has been pressed. Okay, and then maybe print send command plus command. So we're gonna make sure that we send the correct command, okay? Because we know that the Arduino side is working. So if we send something from the Raspberry Pi to the Arduino and if it doesn't work, well, we probably know that this is because we sent the wrong thing. So if we just print the thing, it's easier to debug. Let's save this as activity 5. And so the Arduino is already uploaded. Let's run here on the Raspberry Pi. Okay, you can see serial okay. And now, well, what I need to do is I need to press on the push button and let's see. Okay, we have an error. And well, actually, okay, the module random has no attribute rand int simply because, well, I have to use I lowercase here. Okay, I have used uppercase, but it is lowercase. I made a mistake. So now let's run again. Serial OK. Let's press on the push button. And you can see button has been pressed. Send command read 125. I press again. Send command, so read again. Here read again with 30. And here you can see blue 237, green 36, green 200. Okay, so every time we change one color, 174 for blue, etc., etc. So now I press Ctrl C. Okay, and you can see adding some prints here on the Python side is very, very useful to see what you send, and then you can check that it's correctly doing what you want to do on the Arduino side. And that's the end of this activity.